So in some of the questions previously, I kind of mentioned that it's kind of nice to know that the shift is done last. And this then comes to the graphing form. And ideally, if we can, we want to do shift last and put it into the graphing form, or what some people would call the factored form, especially for the x's, because it kind of simplifies things for the x's if we know that the shift is always last. So if I put it into the graphing form, I factor out the b, this is why it's called the factored form. What will end up happening naturally is when I undo this, I'm going to undo the expansion compression first. So I'm going to expand and compress first and then shift last. And that gives me the indication of where the vertex is going to be. So for this square root function, if I compress and expand first and then shift last, I know my vertex will be at P, just like with the quadratics. And the y-coordinate of the vertex would be that vertical shift on the outside. So shifting last is ideally the best thing. It's not always possible, but when we can, it kind of helps us find the vertex. So in this case here, if I want to see what the vertex is, which then allows me to figure out where the graph starts in the domain and range of the graph, I want to put this into factored form. Okay, so I'm going to put this into the graphing form or the factored form. So I get 5 square root, and it's in the inside then, I'm just going to factor out that 2. And I'm going to end up with x minus 4. So these are equivalent expressions. The difference now is this one shows me where the vertex is. That minus 4 is going to be where the vertex is, because when I undo this, so I'm just going to show you off to the side here, because we don't really need to do this every time now, is that in the factored form, that's my notation, and when I undo it, I'm always going to undo the times divide factor first. So I end up with compressing first, then shifting last. Okay, so this is the ideal scenario if I can do my shift last. Because when this shift happens last, then my domain is related to the vertex. So my domain becomes 4, and I know it's going to the right, so it's going to be greater than or equal to 4. And then my range is going to be, there's no shift or anything with my range, so my range works out to be 0 and greater than or equal to 0. So we can do the same thing here, except make sure when I do this, I want to make sure this is in graphing form. Okay, so what I'm going to do is make sure that when I get rid of these outside brackets first, and that will free up my graphing form for the y. Okay, so I get 2 in the square root part. We're going to do the square root after. And then the minus 6, okay, because I have to distribute into those brackets. So I can see that my vertex is going to be at y equals minus 6, and it's been vertically flipped, so I know it's going down from there. So from there, I can actually already establish my range. So my range is going to be negative 6, okay, and it's going to go down from negative 6. Okay, so I can see that based on my transformations here. With the x, I'm going to factor that 4 out, fact the negative 4, and I end up with x minus 1/2. Okay, so that's the factored form. If I multiply back in, I get minus 4x plus 2. Yeah, that's exactly what I need. And that also now tells me, since it's in this form, I'm going to compress and flip first, and then I have my shift of negative 1/2 last. That's where my vertex ends up. Okay, so this factored form is actually very useful that way. So I know that my x is going to start at 1/2. It's been horizontally flipped because of that negative. So I know I'm going to go to the left. So it's got to be less than the starting point of 1/2. So there's my domain and range from there. So again, the main idea is this idea that we can use transformations, we can use domain restrictions, we can use this to help us figure out what these graphs look like. Right now we're doing this more specifically in the context of finding domain and range, but really this is more the bigger picture of this is about understanding how graphs work and how to find pieces of graphs and how they behave. And just so that we're clear, the domain is going to be much more important to us than the range. If this range is too complicated, we're just going to say it's too complicated for us right now. We'll wait till we learn some more math before we do the range. But the domain is important. Okay, so this one here, we're going to do the same thing. Okay, I'm going to make sure that I have my vertical expansion and my shift separate and clear. So it's going to be flipped and compressed vertically. Okay, the compression doesn't actually affect the range, but it does affect the graph. Okay, and then I'm going to shift it up 3 plus 3. Okay, so then my range, I'm going to work out my range right now. I know it's gone up 3, so that's the starting point at 3, and it's been vertically flipped, so it's going to go down from there. So there's my range. Okay, my domain, I've got a lot of stuff going on in there. Okay, so I really want to put this into factored form. Ooh, that's a lot of work, but so I'm going to do it off to the side here because I need to be able to regroup this into factored form. So first thing I need to do really is to expand this out. So I'm going to expand this out, okay, and divide it by 2. Since it's divisible by 2, it's kind of nice, so it's going to work itself out nicely. So I'm going to put 2 minus 2x plus 6 divided by 2 plus 1, which I'm going to write as, I'm just going to leave it as plus 1. So I'm going to end up with 2 plus 6 divided by 2 is 4 minus 2x, and that's all divided by 2. Oh, sorry, that's going to be 8 minus 2x all over 2 plus 1. This is going to be 4 minus x plus 1. So I'm going to end up with negative x plus 5. I want the factored form, so I'm going to factor that negative out and do it like that. So there's my factored form of that original expression, and that's what I'm going to do. And this is not the undoing, right? This is all notation. This is my notation to start with. This is my notation to end with. I'm not solving for the other x here. So now that I have the notation, I'm going to put that into my notation. So there it is. Okay, and since it's factored form, I know I'm going to flip it first and shift it last. That means that my domain starts at 5. It's been horizontally flipped, so I'm going to go to the left, so I need to have numbers smaller than 5. So that's my starting point, and I'm going to go left because of that flip. So now this is just another way we can look at and use transformations to help us figure out the domain and range. And again, the domain and range is kind of a smaller issue, and the bigger issue is understanding how the graph behaves. And so this factored form is another way we can help us figure this out. And this factored form, the key to this and the main value of this is the factored form allows us to find the vertex or starting point. So it allows me to see the shifts. Okay, the shifts last, so this is where my reference point is going to be ending up. It's going to be at positive 5, positive 3. It allows me to see those reference points much more easily because everything's been compressed and expanded beforehand and then shifted into position after. So these are my reference points. This is in this case represents my vertex. Here, these coordinates represent my vertex. And so this factored form is another way we can understand graphs in general, but also help us figure out domain and range for these particular problems.